Hello and welcome back to the course. My name is Piyush. This is day 18 in 30 days of AWS Terraform. And in this video, we'll be looking into an end-to-end project for AWS Lambda using Terraform, obviously, because this is a Terraform focus series. And I'm gonna show you what the project is, how it will work, how it will trigger the Lambda function. Make sure you understand the basics of Lambda before watching this video, because this is what I have mentioned in the beginning as well. Like, you still need to have some sort of AWS fundamental knowledge to start with this series. Okay, I'm gonna explain you a little bit about Lambda and how does it work, and I'll show you everything. I'll show you the demo, I'll walk you through everything, and make sure you complete the video. And after that, you try to implement this project on your own. You can obviously clone the GitHub repo, but make sure you understand the Terraform code behind it. Make sure you understand the logic behind it. Only then you'll be able to grasp the full potential out of this video, and you should be able to complete this without any issues. And obviously, if you face any issues, then you have the access to our Discord community. You can surely ask your question over here, provide the doubts, provide your errors that you are facing, and someone will help you out. Okay, so without wasting any time, let's start with the video. But if you have not subscribed the channel, please do so. Please share the video and the series with your friends, colleagues, and whoever you think could take the advantage of this learning opportunity. Okay, so let me show you my screen and let me walk you through what we'll be doing in this video. So this is the project that we'll be implementing. Before that, let me give you a brief introduction about how Lambda works. Okay, so let's just start with that. And what exactly is a Lambda, right? So Lambda is what? It's a serverless function. Okay, what do we mean by serverless over here? So you see two different things. So there is serverless, so there are servers, and there is less. So servers such as EC2 instance, any computing system, any computing service that you have in cloud or on premises or data center or your own home lab, that is actually a server. But what do we mean by serverless here? It doesn't mean that there'll be no servers. Yes, there'll be servers, but you will not be managing it. Who will be managing it? AWS will manage it for you. Okay, so you don't have to worry about managing the servers. That's what we mean by a serverless function. Okay, as simple as that. Now, how does it work? Whenever you create an application, okay, so what do we do? Basically, let's say you are over here. Okay, you are a user. Whenever you have to create the application, first you provision the infrastructure, or what we can say, you provision the servers. Okay, so this is what you do. You provision the server, and then on this server you actually deploy your apps. Okay, so that's the basic simple flow that you take. Okay, you provision the server manually or using Terraform or any other CLI API calls, whatever method you use. You first provision the server and then you deploy your app on the server. But then you have to manage your servers on your own. And this server, important point to remember over here is, this server has to be running all the time. Okay, because this server is hosting your application, this server is hosting your web app, and it has to be running all the time so that users can access at any time. If it's a production server, if it has live application, right, it has to be running all the time. That's the important point to remember. But in case of server function, the server doesn't run all the time. How does it work? So let's take the same example, and over here you don't provision the server, you actually create the function. Okay, you write your application code, and then you upload your code to the server. Okay, upload your code to the function, not server. You upload your code to the function. Now this function shouldn't be running all the time. Now this function will be triggered based on an event. Okay, important thing to remember is this function will be triggered based on an event. I'll explain it to you what exactly is an event is over here. So let me just add the details over here. Trigger. So there is a trigger. This trigger could be a time-based trigger. That means execute the function on every Monday morning 7 a.m. or whenever a file is uploaded to an S3 bucket, or whenever, let's say, the server load is 80%, based on an event. That could be a scheduled event, that could be a real-time event. Okay, so this event triggers this function, and function executes, it completes, and then it stops. Okay, so this function doesn't have to be running all the time. Now, the life cycle of an event, like the typical life cycle, event triggers the function. Okay, event triggers the function starts, function does the code execution, and then it stops. That's the typical life cycle of a serverless function. In AWS, this serverless function is called Lambda. Okay, so let me just, okay, yeah. So event triggers, this could be a time-based trigger, or this could be a real-time event. It triggers the function starts, it does the code execution. So this is the code that you write for the Lambda function. Okay, there are multiple supporting languages. Python is one of those language which supports this Lambda function, and then it executes it, and then it stops. Typically you use this function when there is a code execution need for few seconds to few minutes, not more than that. I believe maximum is 15 minutes that is recommended. If your code execution takes more than 15 minutes, then you should not be using a serverless function such as Lambda. So an example of this type of serverless function is this that we'll be implementing. So what this will do, we'll create a Lambda function. This Lambda function will do the image processing. Okay, what it will do, so there are two buckets, two S3 buckets. One is a source bucket, one is a destination bucket. So we are uploading a file to this source bucket, and as soon as the file is uploaded to this S3 bucket, it will create an S3 event. Okay, an event will be triggered that will trigger this Lambda function, and that Lambda function will convert this single file into 5 separate files in different format and compression algorithm. So we'll be creating a JPEG file with 85% compression or 85% quality, then another JPEG with 60% quality, then a WebP, then a PNG, and a thumbnail with this size 200 by 200. And this all be done automatically. You just have to upload the file to the source bucket. This upload can be done by API call, by AWS CLI commands, by console, doesn't matter. The event will be based on the file that is uploaded to the source bucket, and this bucket will trigger the Lambda function. Now this bucket will have permission to trigger the Lambda function, and this Lambda function will have the permission to get the event from the bucket. Also, it has the permission to get the files from the bucket. So it should have the get object list, get object, and get object version from the source bucket. And it also has the permission to upload the processed file, all the 5 files, to the destination bucket. So it should have the put object and put object version permissions for the destination bucket. And this Lambda function will also have the permission to generate logs. So it will create a separate log stream in which you can see the logs of the Lambda trigger, what processing has been done, if there are any errors, if there are any info messages, all those will be uploaded to a log stream in CloudWatch. So we'll be implementing all of this in this video. Okay, try to understand this first before you move into the demo part, because it's important to understand the architecture, what we'll be doing before we actually do the hands-on. And this all will be done using Terraform. Okay, because this is obviously a Terraform series, so it has to be done using Terraform, but you can try doing it manually as well if you want, and then try implementing the automation using Terraform. Okay, so yeah, let's go ahead in the day 18 repository, the same GitHub repository that you've been using for a while, and it will have the Terraform files over here. It will have some scripts so that you don't have to build the projects manually. I'll walk you through that as well. And here is the what I have already shown you. Yeah, so same thing, these are all the components. So you upload the file to S3 bucket for the original image, then destination bucket for the process S3 file. There is a Lambda function for image processor with 𝗏𝗀 library. 𝗏𝗏 is what? 𝗏𝗏 is a Python image library for image processing that we'll be using in the Lambda function. Then there's a Lambda layer for image manipulation. And then there is S3 event trigger that automatically invokes Lambda on upload, right? So whenever the file is uploaded to the S3 bucket, it invokes the Lambda function, or it triggers the Lambda function, because for that Lambda function, any file uploaded to S3 bucket is the trigger. Remember when we talked about trigger over here? So event triggers, it could be a time-based trigger, or it could be an event, a real-time event such as a file uploaded to S3 bucket. So that's a type of event. Okay. Now you can do the deployment using deploy.sh, or you can manually execute the commands. I will show you that. And then you can upload a file. Well, this could be any JPEG file, JPG file, doesn't matter. And upload the file to the S3 bucket, and then you can see it. So let's start with reviewing the code, and let's start with executing it. So I have cloned the repo. The first step is to clone the repo. Okay, because if you have cloned it earlier, it might not have the latest code. Okay, and yeah, so day 18 have the latest code, day 18 folder, the same repo. I have cloned it. Now there are different files. Okay, so let's go ahead and first review the code of Terraform, and then we'll be looking into the Python code for the Lambda function. Okay, so it starts with there is the main.tf file. So we'll be creating a random resource for creating the suffix for the bucket name, because bucket has to be unique, right? So we'll be creating a random ID for the suffix. So a random ID resource. Then we'll be creating some locals to set the variables for bucket prefix, upload bucket name, process bucket name, and Lambda function name. Okay, so these all will be created on runtime based on your project name, bucket prefix, and environment, right? And based on the random ID as the suffix. So we are adding the random ID suffix over here at the end of the bucket names. Okay. So this is something that we have done multiple times. So I'm not gonna get into how do we do string interpolation and how do we create locals. We have done it countless times now. Okay. So then we start creating S3 bucket. So resource is of type AWS S3 bucket, and here is the bucket name which we are getting from the local. Okay. So if we check local upload bucket name, which is this one, which will have a bucket prefix. Okay. Bucket prefix is this one, which is project name hyphen environment, and then upload and the random ID. So that's the bucket name. Source bucket will be created with this code. Okay. Now the next is bucket versioning. We are enabling bucket versioning. Simple versioning configuration status is enabled. Then we are also enabling server-side encryption. Okay. Why? Because we need to improve the security. So we are just creating a rule that says SSE algorithm AES 256 and implement this. Okay, again, this is something that we have done earlier, and we are making the bucket as private, right? It's a private project. It doesn't have to be public. If it's a public project, if it's a production environment that you have, then maybe you allow the public access, or maybe you do it via some other route by placing some other application in front of S3 bucket using the origin access control or whatever. But for this project, I'm keeping this bucket as private. So block ACLs, block public policy, restrict public bucket, everything has to be true. Okay. Then the other bucket for the processed images, which is the destination bucket. Doing the same, we are creating the bucket, we are enabling bucket versioning, and then we are enabling server-side encryption, and we are making the bucket as private. Same thing. Okay. Now we need to create IAM roles and policies. So first IAM role for Lambda function. What is this? AWS IAM role. So this has a policy. Okay, and this is also, I have shown you earlier, how do we create a policy document. So there is an AWS policy generator. You can just search AWS policy generator. Okay, go inside this. Okay, and you can easily create a policy. So you can select different drop downs, type of policy, effect, and then generate policy. Once you generate the policy, it will generate a JSON document, something like this. Okay, and then you encapsulate that inside the JSON encode function and assign the value to assume role policy. So what we are doing, we are assuming the role of AWS Lambda for this Lambda function. Now the policy which will have the permission to do certain actions. Okay, what certain actions? So remember when we discussed this diagram over here, okay, it says it should have certain permissions to get the event from S3 bucket, to get objects, to put objects to the destination bucket, and also to put the logs to the CloudWatch metrics, right? So for that, we are creating this policy. So first action is allow on create log group, log stream, and put log events, okay, for the logging. Then resource is like all the resources within your AWS region. Then similarly, we are allowing S3 object, get object, and get object version on the source bucket. So S3 dot upload bucket. And the same thing we are doing allow on put object and put object ACL on the process bucket. Okay. So if you see the resource is different over here, we are providing the permission at the very granular level to improve the security. We are not providing anything like S3 admin or S3 full access, right? We are providing only the permission that we need. That's the principle of least privilege access. Okay. So upload bucket will have the permission to get object and get object version. Destination bucket will have the permission to put object and put object ACL. Okay. Now here's the Lambda layer. What we are doing? So Lambda layer will have different parameters. Okay. So file name, which will have the layered zip file. So this is like a compiled version of the binary, you can say. It will have the pillow layer and all other dependencies. And then you can just provide the layer name over here, the compatible runtimes, and the description. Okay. And here is the actual Lambda function that will do the work. So first, there is a data source for function. We are getting the source file and output file from here, and type is zip. This is a data, right? Data source for the archive file. Archive file, because we have a zip file that will be creating. That zip file details will be taking from the data source. Okay, so data source, we use it for getting the details of an existing resource, right? So that resource could be in cloud environment, or that resource could be a local file. So in this case, we are using an archive file, which is a zip file. We are getting that details from here. Okay. Now Lambda function, this is the Lambda function. What it will do, it will have a file name. Okay. The function name, role is what we have created already, a handler, and we have created a Lambda handler as well. No, Lambda handler we have not created, but it will take from the Lambda function itself. So Lambda function is, okay, so this is the handler name that we are providing. Then source code hash, we have to provide a hash, which is 𝗏256, output of the zip file, runtime and timeout, memory size. So we specify all the parameters over here, and these details you can completely verify from the documentation as well if there is any change in that. And then we provide the layers detail. We are using a pillow layer that we have created earlier, right, over here. So the layer detail we are getting from there. There could be multiple layers. That is why it is a list. And then there is some environment variable. So we are setting the process bucket ID and the log level. Okay, because the Lambda function that we have created expect a process bucket ID. Oops. Right, and the log level. Now this is the detail for CloudWatch log group. We create a log group named this, and retention in days is 7 days. So after 7 days, the logs will be purged. You can set it to a higher number if you want. S3 event trigger. Now Lambda function will be invoked by S3, right? But that bucket should have the permission. That function should be executed based on the event uploaded to S3. So this is that event trigger. So we provide statement ID, we provide action. Action is what? Lambda invoke function. Okay. function name. So this function will be invoking and the principal is S3. Now this is the source ARN on which the trigger will be applied. So this is permission for S3 event trigger. Now once that is done, you will be uploading the file to the destination bucket and then it will trigger a notification. Okay, that object has been created which is dependent on this. Okay, so this is the entire code. Make sure you understand each and every resource that we have created. There is nothing new that I have done with respect to like with the code. We have seen it earlier, we have seen it multiple times, but make sure why we are creating any resource and what we are creating. Okay, that's important to understand. Yeah, so now you go ahead in the scripts folder and this is where you should start your execution. So you can directly click on deploy.sh and it will take care of all the dependencies and everything, right? So what it is doing, or you can manually run all the steps. What it is doing, it is setting some variables, okay, and it is checking if AWS CLI is installed or not, and then it is building the Lambda layer, okay. So it is calling build layer.sh, which is over here. What it is doing now, it is creating some temporary directories with this format. So this pillow layer expect the package to be inside this exact folder. So it has to be the same, right? So that is why it is there. And then it is installing pillow pip install on this particular layer. Then it will zip the file inside that directory and it will move that zip directory to the Terraform directory. Okay, so that is what it is doing for the build layer. Let's go back to deploy.sh, and in that what we are doing, we are just building the layer. Okay, so we have built the layer already, and then using that we can just initialize the Terraform. We can plan and apply the Terraform plan. So all the tf commands in the same order: tf init, plan, apply, and so on. Now you will get some output over here about the bucket details and all of those, right? So over here is terraform.tfr. Let's just rename it to, currently it's terraform.tfr.example. Let's remove .example and we can make any changes in this file over here, right? So AWS region, environment, project name, lambda timeout, lambda memory size, allowed origin is star for now. But if you have a production application, you can allow origins by providing your domain details over here, right? Now there are some variables for AWS region, environment, product name, the same thing, like for which we have set the values, right? And in output, we have the bucket names, the lambda function names, and the upload command example so that you can run the AWS CLI commands from there, right? So let's go ahead and let's trigger this. Okay, we have not discussed the Lambda code over here, but you can go through it if you want, if you have knowledge on Lambda, or you can take help of any LLM to understand this code. Like you can just open GitHub Copilot in the agent mode and ask, explain this Lambda function step by step, and it will explain it to you what we are doing. Okay, so for now, let me just remove it. And okay, let's just close this. And over here, let's go inside scripts and run deploy.sh. This deploy.sh will do everything for you. It will install the build layer. It will run the Terraform commands. So here is all the, like it has installed the pillow layer. It has created the zip and it has uploaded the zip in the temporary directory. And then it will run Terraform init. It will run Terraform plan and finally Terraform apply. So this is the plan. Okay. And plan has 16 resources to be created. And there are the output variables. Now it is applying the changes. Okay, so let me just pause the recording while it is doing its work. Okay, it has completed. Now it says deployment completed successfully. This is the upload bucket and this is the processed file bucket. And this is the Lambda function. This is the region. If you want, you can upload an image using this AWS CLI commands, or you can do it manually as well. So let's go ahead on our AWS console and let's see if it has been completed or not. Let's go to S3 bucket. Okay, and here you see there is image processor dev processed and image processor dev upload. Okay, so let's go inside dev upload. You don't see anything over here in the dev upload, and in the dev processed as well, this is empty. Okay, so let me just duplicate this tab, and the processor is the, oh sorry, this one is the process bucket, which is the destination. This is the source bucket. Let's open the source bucket over here, which is dev upload. Okay, so let's upload a file to dev upload, and then we'll see if it triggers the Lambda function or not. So add files, and let's upload any file over here. Let's say this one. Okay, and hit upload. Now as soon as you upload, let's open a new tab, duplicate this and open Lambda, and there will be a CloudWatch group created. There is this Lambda function that we have over here, and if you click on that function, you will see all the details about this function, including a code, like this the entire code of the Lambda function. And here is the layer as well, the pillow layer that we have created. And if you can test it, if you want to test it manually, you can simulate the event from here manually, right? And then here is the CloudWatch metrics dashboard that you have. Here are the CloudWatch logs. It says recent invocation are none. It will take some time to trigger the function, because for the first time Lambda takes the cold start, so it will take some time. But once that is done, you will see the option over here. And so this is the dev upload, and let's go over here and see if anything is here. So the file has not been created yet, so let's wait for some time, and let's go over here as well, set refresh. Okay, you see some logs, recent CloudWatch execution, and if you expand this, it will say, it will provide you the details, the metadata. Okay, and because this is the info message that we have logged only, so it will show you the info only, and it will show you the duration in seconds, like the function that it took to trigger, the memory that it used, and the build duration. Because the important thing again to know about Lambda is you will be charged based on the time for which your code has executed, right? Because that's how Lambda works. Now let's go back and see the process bucket. Okay, the objects are still not here. Let's wait for some time. Okay, let's see if there are any more logs generated over here. Let me hit refresh. Still have 2 log entries. And in the configuration, this is the trigger, which is anything uploaded on this dev upload. Okay, the event type is S3 object created, and destination, I don't see the destination over here, so there might be some issues with the destination bucket, right? So let's go ahead and check. There is this environment variable which says process bucket as this. Okay, let's go ahead and check why it is not taking it. You can check the logs as well. Is there any command for logs over here? I don't think so. Maybe the file format that I have used is not. Let's do one more thing. Let's upload another file because the file format has some spaces and special characters. So maybe there is some error handling that I haven't done for that. So let's upload one more file. Add files. Let's rename this file. Okay. Okay, it's already there. Let's see. Date to new. Okay, and upload. Okay, so I'm just gonna pause the recording and let it do the processing. So let's check the logs. So I'm gonna hit refresh over here and see if it triggers another function or not. So as you can see over here, it shows some data now. These are the function executions that have been done, and here are some latest logs. Over here, this is the log in which we have just provided the info, and it will just provide you the metadata, right? The important thing to get from here is log stream and log group. So over here will be the actual details of the logs. So let's duplicate this tab and let's open the CloudWatch log stream to see the actual logs if we have any error or not. Okay, so let's go back to CloudWatch. And inside that, go to logs, log group, and we have this image processor log group over here. Now inside log stream, this is the log stream that we have, and here are the logs. Okay, it says let's see the execution start, and here are some errors. It says unhandled exception, likely an issue in the function code. There could be issues with the runtime. It says, and over here it says unable to import the module lambda function, cannot import name imaging. So there is some issue with the lambda code for which we are getting this error. So it should be inside lambda function. Okay, what we are importing is, let's search over here. Oops. Imaging. Oh, there is no imaging. It might be coming from the pillow library that I have imported. Unable to import module lambda function. Okay, and it is coming from, yeah, it is coming from the pillow layer that I have installed, right? So this is fine. Import pillow could not be resolved. From pillow import image, and then using that it has built a layer, but it has cleaned up the layer already, so I cannot check that. But here is the zip file for it, and pillow layer.zip. So let me spend some more time on it and let me get back to this video. So I'm just gonna pause the recording again. All right, so after spending a few hours, I was able to fix out the issue. So what the issue was, it was the classic issue that I have been teaching you guys for a long time. It works on my machine, remember? So whenever I say this phrase, it works on my machine, it means that there is some dependency issue, something that is working on the local machine, but it breaks as soon as I move it to cloud environment or some other environment. The same issue. So when I compiled the code over here, I compiled it locally on my MacBook, right? But when Lambda process it, when Lambda uploads it, it uploads that dependency and everything on an AWS Linux machine. So there is the dependency issue. The package does not work over there. So that's why we needed the same solution, for which we always say it works on my machine, and the solution is Docker. So what I did over here, so it says build the layer using Docker. Now instead of running all these commands like pip install, creating the zip, and manually copying the file to the directory, what we are doing now, we are doing everything in a Docker container. So I've updated this build layer sh, and everything is now running inside a Docker container. As you can see, Docker run, and installing pillow, and then updating the repository, doing the zip and uploading the zip to a output directory. Everything will be done on the Docker container so that we don't run into any compatibility issues, right? Now I have destroyed the infra and I have created it again. So there is a destroy.sh. You run that and it will destroy everything, or you can run Terraform destroy commands manually. Basically, this is doing the same, but make sure your buckets are empty before you try to do that, right? Because if you know, like buckets cannot be deleted if it has some file, so you need to empty the bucket. And those objects were not created by Terraform, it was created manually. So manually clean it up and then run destroy, and then finally run this again. So after this, I see the bucket is there, like there is a dev upload and dev process bucket. These are the new buckets that have been created. So inside dev upload, I'll go and upload a file. Okay, and click on add files, and let's use the same image. Click upload. In the other bucket, which is dev processed, there is no object, right? But if you wait for a few seconds, that's it. It was so fast. The application is not running, but it's an event trigger. So as soon as the Lambda detects that there is event over here, it triggered the Lambda function. So there is an S3 trigger, it triggered the Lambda function, and it created 5 files as per the logic written in the Python code. So there is this compressed JPEG, then a low quality JPEG, then there is a PNG, a thumbnail with 20 by 20, so you can see the file size because it's a small size, and then there is WebP extension. So all 5 files are created, and this is what we were trying to do. So you can check the logs inside the log group. You can go inside the log group, and here is the log group. Over here you can see the latest log stream, which is 32, this one. Okay, over here now you won't see any error. It says started runtime Python version this, AWS Lambda, found credentials, and then receive event. So this is the trigger, right? It says receive event. Event was object created on the S3 bucket, on this bucket, which is the source bucket, and this is the key. That means this is the object name. Okay, and as soon as find it triggers the Lambda function. It says processing image, and it created multiple variants, and it uploaded those variants to the destination bucket and then successfully processed. And here it ends the Lambda function with the end request ID, and here are all the details. Like it says maximum memory used was 116 MB. This is the memory used by the Lambda function. This is build duration, that means you will be charged for 3 seconds, and the duration was 2.5 seconds something. Okay, so yeah, that's it. Now if you want to clean up, make sure you empty the buckets. So if you go to the bucket, both the buckets, dev processed, empty. Why we need to do empty? Because it has multiple versions, right? So you won't be able to delete it manually. And then empty, this is dev processed, and then you can check the dev upload bucket, which is this one. Buckets, dev upload, empty, permanently delete. Okay, and now you can go over here and run destroy.sh. Now this destroy.sh, if you can check, it has nothing, but it will check if Terraform is installed, some basic pre-checks. It will get the bucket names for Terraform states. It's a reliable option, and then it actually should empty the version S3 bucket, but somehow it's not doing that. Maybe some issues with the logic. And then it deletes all the object markers, and then it empty the bucket, and then it finally run Terraform destroy. So now that destroy has been completed, 16 resources have been destroyed. Alright, so that's it from this video. I hope you enjoyed it. I hope you found it valuable. Keep supporting, keep learning, and keep doing practice. Make sure you complete the task given in the day 18 folder. There'll be task.md. Complete that and do the submission. I will see you tomorrow with the next video. Thank you so much for watching. Happy learning.